I call this talk Nature's Best Hope. And I'll give you a spoiler. You're nature's best hope, not just because you're park managers, because you're part of humanity. It's going to be all of us on this planet that save nature in the future. So now you know what nature's best hope is. I'm really going to tell you about why I think we're all nature's best hope. But before I do that, let's talk about what E.O. Wilson's idea of nature's best hope was. The late E.O. Wilson, he died 2 years ago, but probably the most famous professor at Harvard, at least in the last century. Extremely long career. And one of the things that was consistent throughout his long career was his efforts to save biodiversity, save life on Earth, not just because he loved it, but because he knew it was essential to our own survival. So in 2016, he wrote this book, Half Earth, Our Planet's Fight for Life. He had one simple message. He said, if we're going to save life anywhere on planet Earth, we're going to have to save nature. We're going to have to save functioning ecosystems on at least half of the planet, or it will disappear everywhere. And that includes humans. So it's a very bold statement. He spent most of the book talking about the science that supports the bold statement that we have to save nature on half of the planet, or it will disappear everywhere. And then he ended the book. He didn't spend a lot of time telling us how we were going to save nature on half of planet Earth. Of course, to a conservation biologist, that's a wonderful idea. We'll just put half the Earth aside, and all of those things that are declining can be in that half. We can be in the other half, and it'll be wonderful. Problem is, half of terrestrial Earth is already in some form of agriculture, and we're not going to get rid of that. We've got 8 billion people, along with all of our hardscape airports and our detritus in the other half. And we don't have a third half to put aside for nature. So how can we realize E.O. Wilson's dream? I think we can, and that's basically what I want to talk about today. But we need a new approach to conservation to do that. Before we talk about that, though, let's talk about what happened on the East Coast in 2019, and actually happened across the country this year. We had a very large oak mass. Members of the red oak group got together and decided to make their acorns at the same time. All right, we're talking about a lot of acorns. Well, I'm easily entertained, so I took one of those acorns and I just stared at it. It was rewarded because an insect tried to chew its way out of the acorn. First, it chewed a little hole for its head. Then it forced its head through there. Then it forced its entire body through that hole. Tight squeeze. And once it's out of the acorn, it's a dangerous time for that larva because it's good to eat. A lot of things are after it. So it gets to safety by wiggling and squirming beneath the soil surface. That takes about 30 seconds. And once it's underground, it stretches in all directions and forms a chamber. And within that chamber, converts itself to a pupa. And then surprisingly, stays in that underground chamber as a pupa for 2 years. After 2 years, it comes out as an acorn weevil. That's what an acorn weevil looks like. A lot of people think weevils have big noses because it looks like they do. But that's actually an extension of the head capsule. And the mouth parts are way down there at the end of that extension. And they take those mouth parts, chew a hole into the center of the acorn, and then they turn around and lay an egg in that hole. And that is how the larva gets into the acorn. Why do they spend 2 years underground? Why don't they come out the next year the way most insects would? Well, it takes red oak acorns 18 months to complete their development. So if they came out the next year, there wouldn't be enough acorns for them. Of course, after they leave the acorn, it leaves a hole, kind of like a true vacuum. And you know that nature abhors a vacuum. And in this case, she spelled it with 3 species of temnothorax ants, tiny little ants where the entire colony lives in the holes made by acorn weevils after they have left the acorns. And if scouts find a new hole in a new acorn, they get all excited because their old acorn is falling apart. So they tell everybody, it's time to move the colony. Grab the larvae, grab the eggs, move the entire colony into the acorn. That takes about 30 minutes. Then they post a guard here to make sure nobody else comes in. And this is where they'll live for the next 2 years until this acorn falls apart. So what's my point with this little story? That's just one of literally millions of very specialized interactions, largely between animals and plants, that comprise the bulk of nature. This is another one, the relationship between jays and acorns. Jays are the primary disperser of oak acorns. They'll take an acorn, they'll fly up to a mile, mile and a half from the parent tree. Then they tap it below the soil surface. And the object is they're going to go back in the wintertime and have something to eat. But for every 4 acorns they bury, they only remember where one is. So for every 4 acorns they bury, they've actually planted 3 oak trees. And a single jay can bury 4,500 acorns every fall. There he is. He's burying the acorn. The specialized relationship between pileated woodpeckers and carpenter ants. That's what they rear their young on, carpenter ants. So you won't have pileated woodpeckers unless you have a lot of carpenter ants, and you won't have a lot of carpenter ants unless you have the big trees that make those carpenter ants. You won't have this beautiful moth, the beloved Emarginia, unless you have mistletoe. And you won't have mistletoe unless you have the big oaks that support that mistletoe. That is the only host plant of that beautiful moth. You won't have 60 species of Western native bees, particularly in California, unless you have the pollen of sunflowers, anything in the genus Helianthus. And it turns out that pollen specialization is very common in our native bees. We have between 3,600 and 4,000 species of native bees, and over a third of them can only reproduce in the pollen of particular plants. So nature is a series of specialized relationships, but the point I want to make this morning is that most of these relationships today are in trouble. As a matter of fact, nature itself is on the ropes. And it's on the ropes because we didn't take Teddy Roosevelt's advice. Way back in 1908, Teddy heard that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, looked out over the edge, and he said, "Leave it as it is." And with those 5 words, he started the process of creating the Grand Canyon National Park. Well, we didn't leave most of the lower 48 states as it was. There's only about 5% of the lower 48 that's anything close to its original pristine ecological condition, and those are largely mountaintops. And that's because we have logged the country repeatedly. We have tilled it, we have drained it, we have grazed it. We've got 770 million acres of rangeland out there. That's 4.5 times the size of Texas, dedicated to cattle. And of course, we've paved it or otherwise developed it. We have straightened our rivers and dammed them. You can spell that any way you want. We have polluted our skies and changed our climate for centuries to come. We've drained our aquifers. We've introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas. In short, we've carved up those natural areas into tiny remnants of their former selves, and each one of those remnants is too small and too isolated to sustain the amount of nature that we humans need, because again, it is nature that keeps us alive on this planet. So why have we done this? I don't know. But I suspect we thought that our nest, planet Earth, was so large we could foul it forever and there wouldn't be any consequences. But there are consequences, and that's why we're seeing some pretty scary headlines these days, like the insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. Followed by this one, North America has lost 3 billion breeding birds in the last 50 years. A third of our North American bird population is already gone. Now, the UN is predicting that we're going to lose 1 million species to extinction in the next 20 years. And they said it 2 years ago, so I guess it's the next 18 years now. This is a prediction, but it's one we have to make sure it does not come to pass, because these are the species that keep us alive on this planet. This is serious business. So I could go on talking about the pox that we humans have delivered upon the environment, and as Shakespeare would say, upon all of our houses. But that's not what this talks about. This talks about a cure for that pox. It's a cure that'll take small efforts from lots of people like you and me, and you park managers have a bigger role than anybody else. But those efforts are going to deliver enormous physical, psychological, and environmental benefits to everybody. Let's return briefly to this headline. The insect apocalypse is here. What does it mean for the rest of life on Earth? Well, back to E.O. Wilson. He told us what would happen if insects disappeared from the planet. And he did it way back in 1987 with this paper, The Little Things That Run the World. And again, his message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants. And if most of our flowering plants disappeared, that would so drastically change energy flow through our terrestrial ecosystems that the food webs that support our vertebrate animals would collapse. The amphibians, the reptiles, the birds, and the mammals would all disappear. The biosphere, the living portion of the Earth, would rot because we would have lost insect decomposers that rapidly turn over nutrients, and all we would have is bacteria and fungi. And of course, humans wouldn't survive any of those drastic changes. There is good news, though, and that is none of this has to happen. We can save our insects, we can save our birds, we can save nature itself, but we're going to have to change the way we landscape in order to do it. Why is that? Well, remember, humans are products of nature. We are totally dependent on the life support that ecosystems provide. We call them ecosystem services. And these are just a few things that plants do that we depend on every single day, like produce oxygen, pretty important, clean our water, slow its journey to the sea where it becomes too salty to use, carbon capture, enormously important today. Plants are pulling carbon dioxide out of the atmosphere, building their tissues out of that carbon, and then pumping the extra carbon they fix through photosynthesis into the ground where it's extremely stable. Plants build topsoil, they hold it in place, they prevent floods, they dampen severe weather, they convert sunlight into food. You know, if we lose our plants, we're going to have to eat sunlight and we will lose weight. What are animals going to do for plants? They provide pest control services. They pollinate nearly 90% of our flowering plants. They disperse plant seeds. So designing landscapes like this that destroy the production of ecosystem services is just not a good idea. Never was a good idea, but today it's a terrible idea because of those 8 billion people that are demanding more and more ecosystem services every single day. Now, as you know, we've got parks and we've got preserves, and they are doing the best they can. But we're still in the 6th great extinction event that the planet has ever experienced, so it's obviously not enough. I think the solution now is to now practice conservation, not just in our parks and preserves, but on landscapes just like this. There have been visionaries through the ages who have recognized that we humans needed to work on our relationship with planet Earth, and Aldo Leopold was one of the most eloquent. He wrote extensively in the first half of the 1900s, and one of the things he said is the oldest task in human history is to live in a piece of land without spoiling it. There have been indigenous groups who have been able to do that for long periods, but our huge Western societies and our huge Asian societies are terrible at doing that. We habitually take more from the earth than it has to offer, completely wrecking an area, going to another place, doing the same thing, not sustainable behavior. But Aldo Leopold had a lot of faith in humans. He believed we were capable of developing what he called a land ethic. He knew we had to use the land. We had to farm and lumber and graze and mine and do all of those things. But he believed we could learn to do it gently enough that we did not destroy local ecosystems. That's what he called the land ethic, and he wrote about it in the Sand County Almanac. What he did not write about was developing a land ethic where we actually lived. And I'm not sure why that was, but I suspect the notion that humans and nature cannot live together. We cannot coexist in the same place at the same time. That notion was so deeply embedded in the culture of Aldo Leopold's day, it still remains in our own culture. He might not have recognized it as an option. But what I want to argue this morning is that not only is living with nature an option, it's now the only viable option that's left to us. In the past, of course, conservationists worked pretty much exclusively where there weren't a lot of people. We now need to turn that on its head and practice conservation where there are a lot of people, because that's pretty much everywhere. And that means we've got to find ways for nature to thrive in human-dominated landscapes, not hang on by a thread, not get diminished every year, but thrive. Where should we start? Well, back to private property. Most of the country's privately owned. 78% of the lower 48 states privately owned. 85.6% of the U.S. east of the Mississippi is privately owned. If we don't practice conservation on private property, we're going to fail, and failure is not an option. And when I use the word conservation, I'm not using it correctly. We do want to conserve any bits of nature that are left out there. Absolutely, that has been our conservation model for the last century, and we want to keep doing that, but it's not good enough. We got to rebuild nature all the places we can. And some people will say, well, you're never going to put it back together again the way it originally was. And they're probably right. But we can reunite enough of those specialized interactions I opened the talk with to create functioning ecosystems, even if it's not exactly what was on a particular place at some point in the past. But in order to do that, we have to start with the building blocks. Not all species contribute to ecosystem function equally, so we have to start with the most powerful groups. And there's two groups we can't do without. One is the flowering plants, and of course the pollinators that allow those plants to reproduce. They are capturing energy from the sun and through photosynthesis turning it into simple sugars and carbohydrates, which is the food that supports just about all the animals on the planet. So now we have the food that animals need tied up in plant parts. If we don't get that energy to animals, we don't have any animals. If we don't have any animals, we don't have functioning ecosystems. Well, it turns out that most vertebrates do not eat plants directly. Most vertebrates eat invertebrates that eat plants. Most of those invertebrates are insects, and not just any insect. Caterpillars turn out to be enormously important. They are transferring more energy from plants to other animals than any other type of plant eater. So if we design parks and preserves that don't have a lot of caterpillars in them, we're going to have failed food webs and eventually failed ecosystems. I'm going to use the Carolina chickadee as an example. That's the chickadee that occurs in my yard in southeast Pennsylvania, but it represents most of the birds in continental U.S. These are the birds that are bird feeder all winter long, eating seeds, and we tend to think that that's all chickadees need is seeds, but actually, even in the wintertime, only 50% of their diet is seeds. The other 50% is insects and spiders. And when it comes time to reproduce, their babies cannot eat seeds at all. Again, true for most birds out there. Babies cannot eat seeds, so they switch to invertebrates, and if they're in a healthy environment, they will rear their young exclusively on caterpillars. And chickadees are not exceptions. 96% of our terrestrial birds are rearing their young on insects, and most of those insects are caterpillars. So there's something special about caterpillars. What is it? There's actually several things special about caterpillars. One of them is that they're soft. Think of this guy as if he's a little sausage with a very thin wrapper. The thin wrapper is cuticle, it's exoskeleton, it's made of chitin, undigestible. And because they're soft, you can stuff them down the throat of your offspring without fear of injuring it. And if you've ever watched a parent bird rear their young, they're pretty rough. The beak is like a plunger. They just stuff it down there. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. Now, some of our smaller birds do chase aphids around, but you want to chase 200 aphids or get one caterpillar. They're very nutritious. They're high in fat, high in protein, low percentage of chitin compared to many other insects, particularly beetles. Beetles are not like little sausages. They're like little tanks. So much of a beetle is undigestible. And many beetles have really sharp edges too. And finally, it turns out that caterpillars are the best source of carotenoids for birds during the breeding season. I mention carotenoids not because I love organic chemistry, but because I'm a vertebrate and you're a vertebrate and birds are vertebrates. And we vertebrates cannot make our own carotenoids. Excuse me. Only plants make carotenoids. So we have to get our carotenoids from plants. And we have to get them from plants because carotenoids are essential components of vertebrate diets. Where are the birds getting their carotenoids from? They're getting it from the prey items they bring back to the nest. But look, carotenoid content is not equally distributed among bird prey items. These first two bars here are types of caterpillars. They have far more carotenoids than other types of bird prey. Here are the adult caterpillars here, the moths and butterflies themselves. They have fewer carotenoids because they're not eating the green leaves. That's where the carotenoids are. And here's the earthworm way over here. So the early bird gets the worm, but he doesn't get any carotenoids when he gets the worm. That study and several others are suggesting that caterpillars are not optional parts of bird diets. They are essential parts of most bird diets. So let's just say most birds need caterpillars. The next important question is, how many caterpillars do they need? Is one or two enough? Or one or two a day enough? It's a good question. So let's go back to chickadees. There's a lot of data on Carolina chickadees. How many caterpillars does it take to make one nest of a Carolina chickadee? One or two is not enough. One or two a day is not enough. It takes thousands, 6,000 to 9,000 caterpillars, depending on the number of chicks in the nest, to get the chicks to the point where they leave the nest, where they fledge. And after they fledge, the parents continue to feed them caterpillars another 21 days. So you're really talking about tens of thousands of caterpillars required to get one clutch of a bird that's a third of an ounce to the point of independence. And if you want chickadees to breed in your yard or in your parks, you need to have all your caterpillars in those spaces because chickadees only forage about 50 meters from the nest. And again, that's a generalization. Most birds forage very close to the nest. They are not flying 5 miles down the road to the nearest woodlot. And if we don't landscape in a way that has all those caterpillars, that's called insect decline. And it's really looking like insect decline is one of the major reasons that we have bird declines out there. We went to the original data set of Rosenberg et al. That's the Smithsonian group who said we've lost 3 billion birds in the last 50 years. And we divided our terrestrial bird species into two groups. The species that require insects, particularly when they're breeding, and the species that do not require insects. So things like doves and finches and crossbills can actually make a little milk out of the seeds they eat, and they don't need insects. And look, that group did not decline at all in the last 50 years. But the birds that require insects declined on average 10 million individuals per species. This doesn't prove cause and effect, but it does suggest that as you take away bird food, you lose the birds. And it's not just birds that need caterpillars. This is the ornate box turtle in the Midwest, just another example. They used to be common. They used to chase armyworm and cutworm outbreaks around and eat hundreds of caterpillars a day. So we need to raise the bar about what we're asking our yards, our landscapes to do. In the past, we've asked them to do one thing, be pretty. Now we have to ask them to do two things, be pretty and ecologically functional at the same time. And that's not going to happen unless you put the caterpillars back in these landscapes. So how do we put caterpillars in landscapes? You add the trees, the plants that support those caterpillars. Seems pretty straightforward, but there is a catch, and that is that most plants do not support a lot of caterpillars. So we have to focus on the ones that do. And we have to focus on the ones that do. We have to be fussy about which plants we choose because the caterpillars themselves are fussy about it. And the monarch butterfly illustrates this perfectly. You can have all the eucalyptus and all the Asian plants that we typically landscape with, all the Mediterranean plants, ginkgo, and all of those things in our yards, and you won't make a single monarch butterfly. The only thing that's going to make a monarch butterfly is one of the milkweeds. That's called host plant specialization, and it turns out that most of the insects that eat plants are host plant specialists. They can only eat particular plants. Why is that? Well, plants have made them specialized. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense. It keeps most of the insects of the world from eating most of the plants of the world, which is why it's green out there. It's not because there's no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. They are too well protected. But we do know that insects eat plants. So how do they do that? How do they get around those chemical defenses? This is where the specialization comes in. 90% of the insects that eat plants can only eat plants for which they have very specialized adaptations that allow them to get around the chemical defenses in those plants. Specialized enzymes that store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that minimize the insect's exposure to those compounds. But it takes a long period of interacting with those plant lineages for all those adaptations to fall into place. And when they do fall into place, the insect is locked into eating that particular plant. This is the reason why our non-native plants are not supporting the insects that we need in our ecosystems. So if we take the milkweeds out of a particular space and replace them with some plant from someplace else, the monarch has two choices: fly away and find milkweed someplace else, or starve to death. It turns out there's three kinds of plants out there: plants that actually contribute energy to local food webs, plants that do not contribute energy to local food webs, and plants that remove energy from local food webs. Oaks are the number one contributor to food webs across the country. In 84% of the counties in which they occur, they're contributing more energy to local food webs than any other plant by far. A good example of a non-contributor would be a ginkgo biloba from Asia. It's a good ornamental plant, has nice fall color, but nothing eats a ginkgo, so it's not adding any energy to the local food web. And a good example of a detractor would be your eucalyptus or any of the invasive ornamentals that not only are they not supporting food webs, but they're escaping where we'll be planting and plant them and replacing the native contributors that are supporting our food webs. So the co-evolved relationships between insects and plants is one of the reasons that I think assisted migration is not a good idea. I know California is thinking seriously about that, bringing oaks and other plants up from the south and planting them in the north. There's two reasons why that's not going to work. First of all, that co-evolved relationship. When you remove a plant from the ecosystem in which it evolved, you're removing it from all of the things that it interacts with. And when you plant it someplace else, those things are not around. So it will not be able to support the food web the way plants are supposed to. The second reason I don't support assisted migration is that climate change is not a gradual warming of the planet. It's an increased variability in our climate. So this is what generally happened in the past. This is the jet stream. And in general, it was fairly mild. It would wobble a little bit, but it was cold up here and more mild down here, particularly in the wintertime. Well, under climate change, we have much more very wide swings in the jet stream. So you get cold snaps that go all the way down into Mexico. You get warm snaps that go all the way up into Canada. It's during these cold snaps that any plant we move up from the south gets nailed. So it's climate variability that we have to think about, not a gradual warming. All I'm trying to say with all of this is that plant choice matters. If we're going to recreate ecosystem function in any place where it's been compromised, we have to choose the right plants. We have to have a functional food web. And if we don't, it's not going to work. And I'm going to give you 3 examples of how well it works when we do choose the right plants, starting with my yard right here in Oxford, Pennsylvania. We got 10 acres of a farm that was broken up. It was a very old farm, been farmed almost 300 years. The last thing they did before they sold the farm was mow it for hay. So very few plants there, especially woody plants. And our job was to put it back together again, which, by the way, we had never done before. But I wanted to see that if I put the host plant of a particular species of caterpillar into this space, would the caterpillar find it, and would we start to be able to regenerate a food web? And the first one I started with is the Canadian owlet. I'd never even seen a Canadian owlet before, but that's what the adult looks like, just like a leaf. You're not going to have Canadian owlet unless you have its host plant, meadow rue. There was meadow rue growing here 300 years ago, but it was long gone because of all the agriculture. So I got some meadow rue seeds from someplace and I planted them, and they grew very nicely. But this was early on, and I actually had very little faith that Canadian owlets would appear out of nowhere and find my little patch of meadow rue. So I didn't even go out and check it for about 2 months after I planted it. But then I was walking by for another reason, and I glanced over. It was covered with Canadian owlets. They had found it right away. I'm still impressed with that. So now we have a good population of Canadian owlets and meadow rue. We've added 2 species to this space. The restoration has begun. Same story with the goldenrod stowaway. That's a misnomer. Actually, this beautiful moth has nothing to do with goldenrod. It's a specialist on this plant, Biden's aristosa, ditch daisy. We didn't have any Biden's aristosa, but I did know where there was some Biden's in a power line cut about 14 miles away. So I got some seeds. I planted them. They grew very nicely. As a matter of fact, last summer, they took over my front yard. That's okay. Well, I had to wait a year for the goldenrod stowaway to find my patch of goldenrod, but they did, and now we've got a good population of both of these. So we've added 4 species to the property. Wanted to see if I get the hackberry emperor to make a living at our house. Not because it's the most beautiful butterfly in the world, but because it belongs here. It's one of the species that ought to be occurring on our property. But as its name suggests, it's a specialist on hackberry, on Celtis. And we didn't have any hackberry. So I got a couple of hackberry trees. I planted them. Had to wait 4 years for the hackberry emperor to find my hackberry, but they did. And now we've got a good population of them. So now we've added 6 species, and that is how the restoration proceeded. I did not plant goldenrod. It came in on its own. And along with it came many of the things that depend on goldenrod, like the beautiful brown-hooded owlet, the Arcigera flower moth, the goldenrod leaf miner, the distinct Sparaginothus, the goldenrod gall moth. There are 110 species of moths and their caterpillars that use goldenrod in the mid-Atlantic states. I planted Virginia creeper. A lot of people around here don't like Virginia creeper, but I don't know why. It's a great native plant. It's got good fall color. It's a good ground cover. It can climb our trees without girdling them. It makes valuable berries for the birds in the fall. And by valuable, I mean they make berries that are high in fat. Our migrating birds need sources of fat, and our overwintering birds need sources of fat. And these berries come from tiny little inconspicuous flowers. You don't even know when Virginia creeper is in bloom until you see this big cloud of native bees around it. It turns out it's a wonderful pollinator plant. So remember, when you're making a pollinator garden, you're making it for the pollinators. If it's not big and showy for you, that's okay. I planted Virginia creeper because it's the best host plant for the large sphinx moth caterpillars that are a primary component of cardinal diets. Things like the Pandora sphinx and its beautiful adult, the lettered sphinx, the hog sphinx, the abbot sphinx, all on Virginia creeper. Want to see if I get the evening primrose moth to make a living in our house just because it's beautiful. I like beauty like anybody else. But we didn't have any evening primrose, so I planted it. The moth did come, spends the day with its head stuffed in the flowers. Sometimes it's crowded in there, but it's always very cute. And I planted lots of oaks. Now, these are just examples of the plants we put back in our property, but I want to focus on oaks for a while because they are such important plants. This is the Bedford oak in Bedford, New York, Martha Stewart land. People argue about whether it's 400 years old or 500 years old. It's enormous. And I hear people say, I'm not going to plant an oak because I won't live long enough to enjoy it. And if you can only enjoy your oak when it's 400 years old, you're right, you won't. But if you can enjoy what your oak is contributing to your local food web, you can enjoy it right away. And remember, that's a new goal now for our restorations. Put the plants that are contributing energy into our food webs. Well, I planted most of my oaks as acorns, which means they were free, or as 2-foot bare root whips, which means they cost $1.50 each. And immediately they started to call in the moths that create the caterpillars that run the food web at our house. Things like the solitary oak leaf miner, Juvenile's dusky wing, the yellow-shouldered moth, Suzuki's promolactus, the red-washed caterpillar, the yellow-vested moth, the orange-tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the pink-striped oakworm, the hesitant dagger moth, the lesser oak dagger moth, the medium dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucolatrix, the orange patch smoky wing, the white blotch heterocampa, the oblique heterocampa, the red line panapoda, the laugher, and hundreds more species of caterpillars have come to the oaks in our property. And look, they come right away. This is a pin oak that's just popped its head above the leaves, and here's a caterpillar standing on the ground eating the leaves of that tree. You don't have to wait decades or hundreds of years for your oaks to start to support your local food web. They will do it the very first year. And in case you think that only the East has good moths, that's not true. There are actually more wonderful moths in the West than in the East. Some of them are quite beautiful, like that one and like that one. I don't even know what the names of these guys are, but they're fantastic. Put out a light, and they will come to your light. Okay, this is what our yard looks like in the summertime. Just to give you an idea, we put a lot of the plants back. Not all of them, still working on it. But my research has shown that if you know the number of species of moths in your local food web, moths, not butterflies. Butterflies are bad tasting day flying moths, which means they're not contributing a lot to local food webs. So if you know the number of species of moths, then you have a very good index of the productivity of that food web. In other words, how many species is it supporting, and the stability of that food web. So 6 years ago, I made it a goal to try to take a picture of every species of moth I could find on our property. I am still at it, but I'm up to 1,260 species of moth. Now we have 10 acres. Pennsylvania is 29.2 million acres. So on one tiny fraction of the entire state, we've got 48% of all the moths that occur in the entire state because we put the plants back. And because so many of these moth species are types of bird food, we've recorded 62 species of birds that have bred on our 10 acres. Not flew by, but bred. Why are they breeding here? Because that's where the bird food is. So why am I telling you this? Well, this is another headline we see all the time. World Wildlife Fund says 2/3 of wildlife have vanished since 1970 from planet Earth. It's a terrible headline. But I'm thinking, gee, not at our house. I am convinced we have increased biodiversity by more than 2/3. It didn't take that long, and it wasn't that hard. We just put the plants back. What would happen if everybody put the plants back? We really could turn terrible headlines like this around. But a good question is, will it work on smaller properties, let's say in suburbia? That's a very good question. So let's go to Margie and Dan Terpster's house in Kirkwood, Missouri. They have 0.6 acres, 18 times less land than Cindy and I have. They're in the middle of a development. All their neighbors have the big lawns. When they moved in, their yard was choked with bush honeysuckle, Amur honeysuckle, another invasive from Asia. So they got rid of that. Then they planted 70 species of native plants, put in a water feature they call a bubbler. And then they sat back and started to count the birds that are using their yard. They're still at it. Actually, this has gone up. It's 154 bird species they've recorded at their yard, including 35 warbler species, an incredible number. Just to compare that to our house, we've only recorded 8 warbler species at our house. So does it work on smaller properties? Absolutely. What about urban yards? Let's go to Pam Carlson's house in Chicago. And I mean in Chicago, her property abuts O'Hare Airport. She has 1/10 of an acre. That's 3 times smaller than the average lot size in North America. She's not connected to any natural area at all. So she's a tiny island in the middle of Chicago. It's a pretty island because Pam is a native plant landscaper and she knows what she's doing. But she did the same thing. She got rid of her non-native plants, put in 60 species of native plants, including a water feature. And then she sat back, she says, with a glass of wine and started to count the birds using her yard. She's up to 124 bird species that have used her yard, including a woodcock. There's Pam's woodcock. If you haven't seen a woodcock lately, go to Pam's house in Chicago. All right, there's 4 things we need to think about if we're going to succeed in a big way, and we need to succeed in a big way. And one of those is to address all the area that we have in lawn. Now, I know you Californians are doing a good job in reducing the area of lawn, but most of the country is not. We've got 44 million acres of lawn in this country. That's an area bigger than all of New England dedicated to an ecological deadscape. Why do we do this? Well, it's a status symbol, and we have to display our Halloween decorations. But there are 4 things every single landscape has to accomplish if we're going to reach a sustainable relationship with the natural systems that support us. Every landscape has to support food webs. Every landscape has to sequester carbon. Every landscape has to manage the watershed in which it lies. And every landscape has to support pollinators. So not just our yards, but all of our natural areas have to do all of these things or they can be improved. Lawn doesn't do any of those things, which is why I keep focusing on it. So let's cut the area of lawn in half. Let's reduce that area. I suggest cutting it in half. I suggest taking spaces like this and turning them into this. I got this picture from Dan Getman. He lives in Missouri. I've never met Dan, but he had this giant lawn and he said, look, I'm putting the plants back, and he sent me this picture. Let's make the math simple. Let's say we've got 40 million acres of lawn. We're going to cut that in half. That'll give us 20 million acres that we can restore right where we live, where we work, where we play. And that'll be a huge area. That'll be an area bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, plus Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, plus the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Add up all this park, still less than 20 million acres. That's enough to create a new park that I'm calling Homegrown National Park. And it'll be the biggest park in the country. It's a real thing now. We've got a small nonprofit. You can go to our website, homegrownnationalpark.org, and register your property, either your private property or the preserve that you are working on the map. You simply put down the location, the amount of area you're being a good steward for, and your little piece of your county is going to light up. And the object is to get the message that everybody is responsible for good earth stewardship. We want that message to go viral, and we want the entire country to light up with a firefly, by the way. And it's free. It's free. So what are we asking? We really are asking people to reduce the area in lawn. We're asking them to plant more natives because they're going to accomplish those ecological goals, and lawn isn't. Remove invasive species that are on our properties. Most people have invasive plants in their properties. They don't even know it. And protect any natural areas. If we're already protecting a natural area, we certainly want to keep doing that. There are real ecological products associated with Homegrown National Park, and a significant increase in biodiversity is one of them. Just watching what's happened on my property tells me nature is really resilient. If we put the plants that are running our ecosystems back, it will restore itself. A measurable reduction in invasive species. If everybody got rid of the invasive species just on their own property, we'd be 78% done. 85% done in the East. That's a very good first step. A significant drawdown in atmospheric CO2. Lawn is the worst plant for sequestering carbon. So if we put anything else back, we're going to help climate change. And we're going to start to build viable habitat outside of parks and preserves. And that's important because any viable habitat outside of a park, any conservation we do outside of a park is going to help conservation inside of the parks. There are also important sociological products associated with homegrown national park. National awareness, not just of what the problems are, but what the solutions are and what our roles in those solutions are. We are trying to change the culture for everybody. We want people to recognize that nature's not optional. It's not just there for our entertainment. It's essential. It's essential for everybody, which means everybody owns responsibility to sustaining it, not just poor park managers. Everybody has this responsibility. We want to convert hope into action. Hope is good, but action's even better. And we want to merge national conservation efforts like Audubon or National Wildlife Federation, California Native Plant Society, all the land conservancies that are out there. We want to get all of the efforts they're doing on private property onto that one biodiversity map so we have a visual of how well we're doing. Remember, we've got a 30 by 30 initiative in this country. We're trying to save 30% of the country by 2030. That is not going to happen unless we include conservation that's happening on private property. So we're going to remove part of the lawn. What plants are we going to put in the areas that once were lawn? I'm going to argue that some of them have to be what I'm calling keystone plants. Remember what a keystone is. It's a stone in the middle of the Roman arch. If you take the stone out of the Roman arch, the arch collapses. Well, if you take keystone plants out of our local food web, the food web collapses because they are making most of the food. Just 14% of our native plants are making 90% of the caterpillar food that drives those food webs. So think of the keystone plants in the ecological house that you're building or in the parks that you're protecting as the 2x4s that are supporting that ecosystem. They're the support system. We cannot build an ecological house out of wallpaper, and that's what we've been trying to do with our ornamental plants for the last century. So as I mentioned earlier, oaks are the most important keystone plant in the country. In California, they're supporting 270 species of caterpillars, over 950 species nationwide. No other plant genus comes close to that. And of course, you have the wonderful tool of Cowscape, which allows you to pick out the very best plants, the highest producing plants in your particular location, because all the plants are geo-referenced. I wish every state had a tool as wonderful as this. So we're going to reduce the area that's in lawn. We're going to use keystone plants. We're going to invite a lot of insects to our properties. Then we're going to kill them with our security light, which is not the goal. This is, light pollution is one of the major causes of insect declines around the country. And these are all the ways that lights are killing our insects. So it's a big problem, but it's also a big opportunity. To me, this is good news. We have to stop insect decline. We have already lost more than 45% of the insects on this planet. And remember, they are the little things that run the world. If we can turn that around by flicking a switch, we're getting off easy. There are a lot of switches to flick, but there's a lot of us to flick those switches. But, right away I hear, well, I can't turn the light out over my barn or over my garage or over my front porch because the bad man will come. All right, put a motion sensor on it so it only turns on when the bad man does come. And the first thing you notice is the bad man does not come very often. And if you don't want to do that, take the white bulb out of your security bulb light and put in a yellow bulb, because yellow wavelengths do not attract nocturnal insects. If we switched out our white bulbs for yellow bulbs overnight, we would save millions of insects. And if we used LEDs, we'd save millions of dollars as well. So we're going to shrink the lawn. We're going to use keystone plants. We're going to modify our light system. Then we're going to invite one of the mosquito fogging companies to come kill all of our insects. I don't know how much you do this in California, but it is a booming business around the country. And these guys say it's okay because what they're fogging is a natural product. It's a natural organic product. And they're right. It's pyrethroids made by chrysanthemums. It is natural and it is organic. But so is cyanide, natural and organic. So is ricin, natural and organic. So is nicotine. There's lots of very deadly things that are natural and organic. They also say it only kills mosquitoes. I wish they were right, but not even close. It kills all the insects it comes in contact with, including our beleaguered monarchs. This is the result of a mosquito fogging event on Kent Island in the Chesapeake. My friend happened to be there. He picked up this handful of dead monarchs, but there were thousands on the ground because it was during a migration event. And it's killing all the pollinators that we're trying to save. The interesting thing is mosquito fogging doesn't control mosquitoes. We're doing this for nothing. You don't control mosquitoes in the adult stage. It's too hard. You have to kill 90% to get good control. These guys kill between 10 and 50%, so they're not even close to being effective. If you really want to control mosquitoes, do it in the larval stage. And this is something that any individual can do. You just get a bucket, you fill it full of water, put in a handful of straw or hay, put it out in the sun for a couple of days to build up the population of diatoms and algae, because that is what mosquito larvae eat. And that will become an irresistible brood to any of the female mosquitoes that are in the landscape. They will lay their eggs preferentially in your bucket. Then you go to the hardware store and you get a sheet of mosquito dunks. That costs $12 for a season's worth of control. It's Bacillus thuringiensis. It's a natural bacterium that only kills aquatic diptera. And the only aquatic diptera in your bucket is a mosquito larva. So it's targeted, it's effective, it's cheap, and it would work if everybody did it. The fourth thing we need to think about is how we landscape under our trees in terms of allowing caterpillars to complete their development. Now, this is just an example. I live in Chester County, Pennsylvania, where oaks support 511 species of caterpillars. A few of them, like the polyphemus moth, complete their development on the tree. The caterpillar eats the leaves, then spins a cocoon and hangs from one of the branches. Then it emerges as an adult. Then it does it all over again. Everything happens on the tree. And I wish everything did that, but most species don't. They will finish developing as caterpillars on the tree, and then they drop from the tree and wiggle their way beneath the soil surface and pupate underground, or they spin a cocoon in the leaf litter that's under the tree, and that's the problem. There is no leaf litter under the tree. We don't tolerate it, and we mow and compact the soil under our tree so that it is rock hard, making it very difficult for caterpillars to get underground, which means these become ecological traps. The moths come in, lay their eggs, the caterpillars develop, drop down, and die. And I am convinced that the way we landscape under our trees, or the way we don't landscape under our trees, is another major cause of insect decline around the country. And of course, the cement landscape is not the answer. So this is what most people do. You've got a tree in a lawn. I've got a grad student now measuring how well caterpillars do in a situation like this. But I guarantee they're going to do better in a situation like this, where you have a layered landscape. Soft landing. The caterpillars fall down. There's plenty of leaf litter down there to spin their cocoons in. The ground is not compacted. Nobody's going to mow them. Nobody's going to step on them. Much higher survivorship. This is where you can use your native ground covers. There's plenty of them. It creates a wonderful place for those caterpillars to pupate. So the object is to put beds under all of your trees. And that, if you have lawn, that is how you shrink the lawn. The tree will love it, and so will the caterpillars. Okay, former grad student Desiree Narango did some wonderful work with chickadees in the suburbs of Washington, D.C. And this is just to illustrate a point. There is room for compromise in our plant choices. She had one simple question, and that was, how well do suburban landscapes that are landscaped primarily with native plants, how well do they support chickadee populations compared to typical suburban yards landscape with introduced plants? And when they're landscaped with introduced plants, they produce 75% fewer caterpillars. So right away, you reduce the amount of bird food by 75%. They were 60% less likely to have breeding chickadees at all. Everybody had a nest box up, but the chickadees would come and look around and say, there's not enough food here. We're not even going to try to breed. If they did try to breed, they laid 1.5 fewer eggs. Those clutches were 29% less likely to survive at all. If they did survive, they produced 1.2 fewer fledglings, and it took them 1.5 days longer to do that. And if you put all that into a population growth model as a function of the percentage of non-native woody plant biomass in your landscape, from 0 to 100%, this is what you get. We looked at woody plants because that's where chickadees forage. This is replacement rate. That's the rate at which the population has to make babies to replace the adults that die every year. Chickadees don't live that long. And if you reproduce at this rate, you have a sustainable population. It's not growing, but it's not shrinking either. If you make more babies than adults die, anything above the line here, you've got a growing population. And that happens when you have very few non-native plants. But if you're below the line over here, where you've got a lot of non-native plants, you have an unsustainable shrinking population. Now, right here is where those lines intercept. So it suggests you can have, very liberally, you can have up to 30% of your woody plant biomass non-native without destroying your local food web. And we can't tolerate any invasives. Invasive plants are just ecological tumors. They just keep multiplying and multiplying. They escape into our ecosystems and castrate local function. But there's a lot of ornamental plants that are not invasive. Remember Dan Getman. This is a ginkgo tree. Ginkgo from Asia. Why does Dan have a ginkgo in his native planting? Well, it turns out that Dan's wife likes ginkgos, and Dan likes his wife. So he planted a ginkgo tree. The question is this plant destroying the functionality of this landscape? No, it's just there. Is it going to escape and wreck the woodlot? No, it's not invasive. So what do we think of plants that are just there, not contributing much? I think of them as if they're statues. They can be pretty, but they're statues. So there you go. There's Dan's statue. If all of Dan's plants were statues, he would not have a functional landscape. But it's not the presence of these non-native plants that destroys food webs. It's the absence of those productive natives. If we increase the percentage of native plants, particularly the productive ones, the contributors, we can tolerate many of these. Can we use native plants in formal designs? Of course we can. This is a Lino Shaughnessy design taken by a drone 400 feet up. You don't get more formal than that, and every plant in that landscape is a native plant. Formality is a function of the design. It's not a function of the plants in the design. Our natives are used in formal designs in Europe every day, and they love them over there. So if Europeans can love our native plants, maybe we can too. Can we add a pollinator garden to a suburban yard like this without disturbing anybody? Of course we can. Just put a little fence around it. It formalizes it. It tells your neighbor it's not just a bunch of weeds you forgot to mow. It's pretty when it's in bloom. It's servicing several species of bees. It's not very big, could be bigger, but if everybody did it, it would help a lot. Help what? Help make pollinators. Why do we need pollinators? Well, the media will tell you because they're pollinating a third of our crops. It's actually about a 1/12 of our crops. And I hear people say, well, I don't live next to a farm, so I don't need any pollinators. Forget the crop argument. We do need pollinators. We need pollinators every place we need plants, which is every place, because they're pollinating 80% of all plants and 90% of all flowering plants. We lost our pollinators, we lose 80 to 90% of the plants on the planet, and that is not an option. Great pollinator plant, California lilac, use it liberally. And our native asters all over the country are wonderful pollinator plants, not just for bees, but for those migrating monarchs that need nectar sources, particularly in the fall. How about this? A Drew Latham design. It's much bigger. Imagine the amount of life supported here versus the amount of life supported here. Seems like a no-brainer. Can municipalities help us live with nature? Of course they can. And many of them are doing it more and more. Minnesota's been doing it for several years now, has a cost-sharing program that encourages homeowners to reduce or replace their lawn with appropriate Minnesota prairie plants. Pennsylvania has a similar program now. Virginia's starting one up. There's an island off of Florida, I think it's Marco Island, that is paying homeowners to allow burrowing owls, listed species, to burrow in the front yard. I think this is the way the Endangered Species Act should have been written, with carrots rather than sticks. If you have an endangered species on your property, we're going to pay you to be a good steward of that species rather than fine you if you use your property. Everybody would want an endangered species. Put a bounty on these invasive ornamentals, like this is calorie pear, terrible plant all over the East. If you take out a calorie pear, you get a free tree replacement. That's what St. Louis, Missouri did. Fayetteville, Arkansas, North Carolina has a bounty on them. Very popular. Water utilities, giving people $100 coupons to plant water-efficient native plants. And of course, the big lawn reduction programs in the far west, particularly California. And you know, this has gone up, $3 per square foot rebate for every square foot of lawn you remove and replace with a xeric planting. And if you want more information on all of those programs, memorize that. Okay, I think we've made 3 missteps in the early years of conservation. And the first one's important. We're starting to think of nature as optional. We like it. We like to go bird watching. We like to ride our bikes in it, just walk around, but it's not essential. And if it's not essential, when push comes to shove, when resources are in short supply, nature takes a back seat, and resources are always in short supply. I went to the Cincinnati Zoo before the virus broke out, and there's this wall-sized poster there, which to me epitomizes our society's view of conservation. We want to save wildlife. We want to save nature so that future generations can enjoy it. That was Teddy Roosevelt's argument for increasing the size of the national park system. They're beautiful places. We want to save them so that future generations can enjoy them. And I get that because nature is enormously entertaining, but it is a lot more than that. We need to save nature so that we have future generations. It's a little bit more urgent. We've also assumed that humans and nature cannot coexist. Now, we talked about that, but if we restrict our conservation efforts just to the places where there's not a lot of humans, we're going to fail because those places are too small, too few, and too isolated. David Quammen has a wonderful analogy between a Persian rug and an ecosystem. This is a functional Persian rug. That is not 71 Persian rugs. That's 71 rug fragments, none of which are acting like a Persian rug. And that's what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance. And I don't like that argument because, or I don't like that language because it suggests there's places on planet Earth with no ecological significance. Not so. Every square inch of the planet has ecological significance, including our yards, including our corporate landscapes, including our roadsides, even including much of our agriculture. So we need to glue our rug back together again, folks. We've got to put the plants back, not just to make biological corridors that connect viable habitats, but to recreate viable habitats in all those places where we've destroyed them. The good news is this is starting to happen. It's starting to happen. When it does, it'll be the first time in modern history that humans have coexisted with the natural world. Our third misstep is to leave Earth stewardship just to a few specialists, a few conservation biologists, few ecologists. For some reason, we didn't see it as an inherent responsibility of every human being on the planet. But I don't know why, since every person on the planet depends entirely on the quality of Earth's ecosystem. So why wouldn't everybody bear the responsibility of taking care of those ecosystems? Stan Rushworth, a Cherokee elder, once said that the Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. You're not born with those mindsets, you're taught them. We've been very good at teaching this one. We've been terrible at teaching our kids and our peers that we all have obligations to good Earth stewardship. That does not mean you have to save biodiversity for a living, but you can save it where you live. And if you do, it empowers you. More and more people are recognizing that the Earth has some serious issues these days, but most people feel powerless. What can one person do? Well, one person can shrink the lawn, one person can use keystone plants, one person can put in a pollinator garden, one person can remove invasive species, one person can change their light bulbs, one person can fire Mosquito Joe, one person can totally invigorate the little ecosystem on their property and then enhance their greater local ecosystem instead of continuing to degrade it. And it also shrinks the problem down to something that's manageable for each one of us. Don't think about the entire planet's problems. You get depressed. Just worry about the piece of the planet that you can influence. If you own property, if you manage property, of course, that's where you focus. That's a no-brainer. If you don't own property, help somebody who does. Help a park, help a preserve. They're all underfunded, they're all understaffed. They will love you as a volunteer. So as a property owner or a volunteer, each one of us has the power, and we certainly have the responsibility to fix dead landscapes like this. Whether or not we do so is going to determine nature's fate and ultimately our own. So I think I've convinced my grandchildren that you are nature's best hope. I hope I've convinced you as well. Thanks very much.